All right. We're going to start our study on trigonometry, and we're going to start by looking at angles.
He doesn't really work on Friday. I only see him on Friday. Oh yeah, I know.
This point right here is the vertex. If we're rotating, this is going to be our initial side. And this is our terminal side. Angle that is standard form has its initial side right here. It just doesn't want to go there. Its vertex is going to be at the origin, and then we rotate counterclockwise, and the place where we stop is called our terminal side. So angles that are in standard position will have their initial side, so to speak, at the 0, 0, and we rotate if we rotate counterclockwise, we have a positive angle. If we rotate clockwise, we actually have a negative angle. So like this angle here would be a negative, I'm just going to use a B to represent it because I can't use negative alpha because they're not the same size.
What does that little circle line thing mean?
That's theta, that's a Greek letter. That's what the letters we use to represent angles. And then the last thing is we're going to use is the word coterminal. Angles. Any ideas on what we mean by coterminal angles? Do we have co-captains of the football team, the volleyball team? So what's that mean? They're the same. They're the same. So if we have coterminal angles, what's going to be the same here? The terminal side. All right. So how does that happen? Well, it can happen a couple ways. Here's our initial side. I can rotate this way. It's going to put me at that angle, and we'll let that represent. Let's just do alpha. And then if we rotate this way, but I still have that same side there, alpha and beta, in this case it's a negative, if it's say negative 100, is going to rotate and have the same side. So if we look at this and we know that alpha, the absolute value of alpha plus the absolute value of negative beta, what are those two angles going to add to? 360. So we have 360 degrees in a circle. Questions there? Then we have, what units do we use? Well, we have radian measure, any of you heard of radian measure to use for angles? One revolution around a circle of radius r equals 2 pi radians. Well, if one revolution around a circle radius r has 2 pi radians, what is the degree of one revolution?
Busker gave them to you the other day?
Yeah, she brought them down yesterday, but they weren't done, so she took them back.
Mary, for the thank you.
You're welcome. So, one revolution around a circle is how many degrees? 360. So that means that 360 degrees is going to equal 2 pi radians. Or we could say that 180 degrees is pi radians. In this section, I'm going to be asking you to convert between degrees and radians, and degrees. Well, 1 degree equals pi over 180 radians. 1 radian equals 180 degrees over pi. Okay, let's look at a couple examples. Example 1, express each degree measure in radians. If I know I have 60 degrees, how am I going to convert it to radians? One degree equals pi over 180. What am I going to multiply this by? By pi over 180? Because this is 60 degrees, and if 1 degree equals pi over 80, I need to know how many does 60. So we're going to multiply by pi over 80, pi over 180, which equals pi over 3. Now, when we use radians, we don't, if they just give, if they give you the angle without anything written out here, if they give it to us in pi, most of the time it is in radians, unless they say pi degrees. But pi over, this is radians. We don't write radians out as a unit. It's just, there's nothing there written as a unit.
What exactly is a radian?
What?
What exactly is a radian?
A radian is another, you know, we have, we can measure length in feet, in yards. Well, we can measure angles in either radians or in degrees. And we're going to come across some formulas here in a couple of minutes where we have to know what the angle is in radians in order to use that formula. Okay, so it's just another way of measuring angles. B, 320 degrees. And then C, we're going to do a negative 30 degrees.
Okay.
Do these the same way. Multiply by pi over 180. We don't want to multiply the pi out. So what I did was I reduced. Well, 180 and 320 are both divisible by 10. I can now divide them both by 2. So we get 16 pi over 9. And what about C? We'll multiply it by pi over 180. And 30 goes into here 6 times. So we've got a negative pi over 6. Questions on converting from degrees to radians?
Will you always use that equation?
For going from degrees to radians, yes. Now how are we going to go from radians to degrees? Yes. So we times it by 180 over pi. What happens to the pi's? They'll cancel. And we'll get 30 degrees here. So 5 pi over 3 we multiply by what? Pi, 180 over pi. Pi's cancel. Reduce here to give me 300 degrees. Now this one doesn't have a pi in it, but it's still a radian measure. So how do I convert this to degrees?
Would you make it a fraction?
Do what?
Would you make it a fraction?
Make this into a fraction by going like that? And then what? What do I multiply by?
180 over
Multiply by 180 over pi. And then here's where you're actually going to use your calculator. You're going to multiply it out. You're going to take 3 times 180 divided by pi. And you should get 171.89 degrees. Pi does not get multiplied out when you're writing it in radians, but it does get multiplied out when you're writing it in degrees. I won't ever see 5 pi degrees. Questions? Applications. First application we have is we can find arc length. What's the arc length in a circle? Here's my circle. What's my arc length? We're talking about that angle. What's our arc length going to be? So it's the length of this arc right here. Part of the circle is between them. And so for a circle of radius r, a central angle theta let's see, a central angle theta intercepts an arc length S. Bless you. Given by S equals R times theta, where theta is measured in radians. That's important. If you don't use the radian and multiply just by its angle, you'll get the wrong answer. A circle has a radius of 27 inches. Find the length of the arc intercept. Intercepted by a central angle of 160 degrees. So we're looking for S. 27 is what? It's our R, radius. And then this is going to be what? It's our theta, but what do I have to do with it first? I have to change it to radians. So 160 over 1, I have to multiply it by pi over 180. S equals R times theta, which is going to be 27 times 8 pi over 9. And you should get 75.4 inches if you multiply that out. I'll give you time to try that, check that answer. Agree? Then we have one more application. The second application is area of a sector of a circle. For a circle of radius r, the area A of a sector of the circle the central angle theta is given by area equals 1/2 r squared theta, where theta is measured in radians. An example is a sprinkler on a golf course. Is set to spray water over a distance of 75 feet and rotates through an angle of 135 degrees. Find the area of the fairway watered by the sprinkler. Sorry, Katie, what was that?
For 135 free storages.
I didn't simplify mine. I have area equals 1/2, what's your radius? 75 squared, and then times your theta. I just left it like this. I'm gonna have to get my calculator out, so I might as well just do it all at once. See what you get.